One last example here from 1 through 3 where we need to identify the center, the foci, the vertices, and the lengths of the major and minor axes. So the center will be the first thing we need to figure out, and the center here is going to be at 1, 5. The largest value is underneath y, so this ellipse will have a major axis that's vertical. If you want to, you can make your quick sketch. Again, not totally necessary, it just helps me visually see what I'm doing. So we've got 1, 5, which might be up here, so that might be 1 and 5, and then it's going to open something like this. Okay. Now we need to figure out a, b, and c. So a squared is 36, making a 6. B would then be 4. Watch out for a common student error here of just taking the 36 and making that a. A squared is 36, so a would be 6, okay? Now to find c, we've got the square root of 36 minus 16, which is going to be the square root of 20. This could be simplified into 2 root 5, and we probably should do that. So c in this case is 2 root 5. Not a Pythagorean triple, not something we can work with as far as integers go, but we can still find the exact distance. If we try to find our vertices now, we need to go right back to our center. And in this case, the major axis is vertical. So for our major axis vertices, the x part is going to stay the same. After all, if you move up and down, you don't go left or right any. And we need to change this 5 by 6, both up and down. So we'll take 5 and add 6, making that 11. And we'll take 5 and subtract 6, making that -1. If we do the minor axis vertices, that'll be in the left and right direction. So this time, always go right back to your center. The y value will stay the same. And it's the x value that's going to change by b. So we need to add 4 to 1, making it 5. And then we need to take 1 and subtract 4, so that would be -3. For the foci, we're going to use c. And this is an interesting case where here we can actually do that arithmetic. We can take 5 and add 4, or excuse me, we can take 1 and add 4, and also 1 minus 4. We can do that, and that's 5 and -3. We really can't do that here, though. We can't subtract the two of them or add the two of them together. But what we can do is we can write out where the location of these things are. Keep in mind that the foci are going to be on the major axis. So we're going to go right back to our center, just like the major axis vertices. In this case, the x value will stay the same. And this one needs to change by both adding and subtracting 2 root 5. So even though c is a distance, we need to both add it and subtract it, so you can write the answer like this. Or, if you prefer, this is a little bit longer, but you can do this. This could be 5 plus 2 root 5. And then we would also want to list 1, 5 minus 2 root 5. And actually, if you were typing this in your calculator, that might be beneficial for you to do if you need to find maybe an approximation, perhaps if you're graphing. The last thing to do is find the major and the minor axes. So the major axis is going to be double A, so that's 12, and the minor is going to be double B, which is 8. So we've got the center, the vertices, the foci, the exact values for the foci, and then the major and the minor axes.